Alrighty. Before I introduce some new stuff today, I want to go over some review material from November. All right, when we thought we were actually going to take a Regents exam in January. So the first half of today's class you guys have seen before already. All right, I just need to wake you up a little bit and remind you how to do it. You guys, I don't know if you remember or not, we talked about Radians. All right, this year, Radians. And what I want to go review with you guys first is how to take a degree measure and put it into radians. And then we'll go backwards. So number one, let's start. Number one, I have 120 degrees. I want to know what is it equal to in radians. And the way we did that was we had a formula sheet that showed the conversion. So instead of getting out a formula sheet or giving it to you, I wrote the conversion right on top of the page right here. If you are in degrees and want to go to radians, that's what you multiply by, pi over 180. So I'm going to take 120, multiply it by pi over 180. If I want to go to degrees to radians, I multiply it by 120 by pi over 180. I know it's in radians if you leave your answer in terms of pi. So what I'd like you to do here is leave your pi in your answer. That tells me and you that you're in radians if you see a pi there. Grab your calculators right now. Grab your calculators. All I need you guys to do is reduce 120 over 180. I want you to reduce it. So go to your calculator, put it into a fraction, 120 over 180, and your calculator will reduce it for you. 2/3. So as a radian, 120 degrees is the same as 2 pi over 3 radians. All right, so multiply by pi over 180. All right, let's go backwards. What if I give you radians and you guys needed to turn it into degrees for me? All right, that's another conversion, which I have on the top of the page. If you start in radians and have to go to degrees, there's what you multiply by, 180 over pi. So 7 pi over 4. Now multiply it by that, 180 over pi. And you guys will see right away what's going to cancel out. The pi's. Gone. The pi's will cancel each other out. So I grab my calculator. 7 times 180 divided by 4. That'll turn that radians into degrees. And hopefully you guys are getting 315 degrees. So hopefully starting to, ring some type of bell here from back in November. All right, number 3. The only thing different is it's negative, so keep the negative all the way through. Still convert it the same way. It's in radians and you want degrees, so pick the correct conversion. Radians, 2 degrees. Again, multiply by 180 over pi. Keep the negative sign all the way throughout. Pi's cancel. Negative 2 times 180 over 3. Negative 120. All right, questions there, comments, concerns? All right, so that's how I convert. Real quick review of converting radians to degrees. Also what we did, which is on your next part, is graphing these. Graphing. So let's refresh our memory on how do I graph. First, you start at 0 degrees on the x-axis, then you go counterclockwise. Then it goes 90, 180, 270 if you remember. Back to 360. Counterclockwise is positive. Counterclockwise. So if I'm asking you to graph 145, first side of the angle is always on the positive side of the x-axis. Always on the positive side. Then you got to put the other side in the correct quadrant. So 145 degrees, would be between 90 and 180 in quadrant 2. And I believe it would be closer to 180, so make sure you put the other side closer to 180. Any of you guys know what I'm missing yet? Because I'm not done yet.
Arrow
Yep.
that shows rotation arrow.
Yep, good. Or an arrow showing me, are you going clockwise or counterclockwise? And since it's positive, I'm going counterclockwise that way. So make sure you put your rotation arrow in. Good, good. Questions? Number 2, now it's negative. So now I go clockwise. Negative 90 will be down here. Negative 180, negative 270, and we're back to negative 360. That's it. Now I go clockwise when it's negative. So again, first side of your angle is on the positive side of the x-axis. And now I should be in what quadrant here? Quadrant 4, yep. Closer to 0 than I am to 90. And then make your rotation arrow going clockwise now, clockwise. Coming back to you a little bit. All right, 295 now, positive 295. Go ahead. Positive 295, graph that. First side on the x-axis, positive side. Now we should be in quadrant 4, closer to 270 than it is to 360. With your rotation arrow going counterclockwise. Okay. Anything right now before we move into graphing radians? Feel pretty comfortable?
So
Feel pretty?
it's counterclockwise if it's
Positive. Correct. Yep. Think about it this way, Carolyn. It goes in the same order as your quadrants.
Oh, right.
1, 2, 3, 4 always go counterclockwise, so that's why it goes positive counterclockwise. All right, let's do. What's up?
And so that makes sense.
Okay, good. All right, let's do radians now. I have no idea what the radians are, like we're 90, 180, 270, and I don't expect you guys to be, but what have we done already today that you can do to the radians to make this problem easier? Convert it, convert it, convert it. Yep, convert it into degrees now. So we're going to take negative 5 pi over 6, multiply it by, you look back on the top of your sheet, 180 over pi. Make it into degrees, and then it makes this problem a lot easier. Pi's go. So now all you're doing, negative 5 times 180 over 6. You guys are graphing negative 150 degrees. All right, so go clockwise now, clockwise with your graph. Still on the positive side of the x-axis, and now I should be in quadrant 3. Oh, sorry, 3. One job. Closer to negative 180. And make sure you got that arrow going clockwise. All right, one more radian here, number 5. 13 pi over 8, convert it in degrees. Convert it in degrees. Yeah, you get a little decimal action here. It's all right. Don't be nervous. You do get a little decimal action. Don't be nervous. $292.5. let's see, 292.5 would put me quadrant 4, closer to the 270 side. Going counterclockwise. All right, let me stop there. Any questions right now? So this has all been review so far, and the next part will be review too. Any questions? Graphing an angle or converting. All right, coterminal now. Coterminal for me. Bottom line, I want you to find an angle that's positive and negative that's coterminal with each of these. Coterminal, ready? Review a coterminal. It's the same angle. I go all the way around in one direction, and it's the same angle. So if I'm at 50 degrees, and I want another positive and negative angle that looks the same as 50 degrees if I graphed it. Notice what I just said. We go all the way around in one direction. What am I telling you to do to 50? Add and subtract what? 360 to it. Correct. All right, so I'm going to take 50. I'm going to go all the way around, add 360, and 50 degrees is the same as positive angle 410 degrees. So we say those are coterminal because they're the exact same angles. But I need a negative version as well. So instead of adding 60, yep, go in the other direction. Subtract 360. Go clockwise now. And we'll end up at an angle of negative 310. Yep. Okay, so coterminal, same exact angle as I go around 360 and subtract 360. All right, 580. You can add 360, that's fine. You want another positive angle? Keep adding 360. Well, that's a large one, huh? 940. So there's my positive angle that's coterminal. Now help me, watch what happens when we find a negative angle though. Minus 360. 240? Nope, 220. But that doesn't answer my question though. It's 220 though. What's up, Ella? Keep going around, yeah. Hey, you could have also had 220 as a positive angle. That would have been fine instead of 940. You could have used that, but I still don't have a negative angle. So yes, I still need to keep subtracting 360. Keep going around and around until I get that negative angle. And I believe I end up with negative 140. Good job, guys. Good job. Any questions before I get to the radian version? Ooh, radians, 5 pi over 6. Give me a positive and a negative. Ooh. I know what some of you are thinking. Let's convert, add 360, subtract 360, and convert it back to radians. That's a lot of work, guys. It's too much work for me, and probably for you too. Yes, could I convert this to degrees, add 360, subtract 360, and then reconvert them back into radians? I could, but that's going to take a while. So instead, what I want to do is I want to add and subtract the radian version of 360. Anybody remember that back in the day? The radian version of 360? What 360 degrees was in radians? Nobody?
Pi.
Is it 2 pi?
Oh,
Isaiah. Oh, easy, Caroline. Isaiah.
Yeah, 2 pi. I don't know how I remember that.
I don't know either, but he's correct. 360 degrees is the same as 2 pi radians. Yes. Good. Wow. This will be a good weekend, huh?
I hope so.
Wow. On fire. I never doubted you. So that's what I'm going to do. Ready? I'm going to take 5 pi over 6 and add the 360 equivalent, which is 2 pi. Don't you dare tell me this is 7 pi over 6. Come on now. These have different denominators, don't they? But this is very easy. Easy. What's the common denominator? Come on now. What's your common denominator for 6 and 1? 6, right? So put a 6 there. The 5 pi stays 5 pi because that's got a denominator of 6. All right, what do you have to multiply 2 pi by? To make the denominators the same, what do you got to multiply 2 pi by? Come on, you guys got this. You're just being shy. How do I turn a 1 into a 6?
Multiply by 6.
Yeah, done. Multiply by 6. Now it's 5 pi plus 12 pi. Done. So a positive angle would be 17 pi over 6. All I had to do was multiply 2 pi by 6. All right, then how do you get a negative angle? Subtract them. You guys did the hard work already. Just put a minus sign in between them now. 5 pi over 6 minus 2 pi. You guys know what it's going to come out to be. Common denominator of 6, 5 pi, but now it's minus 12 pi. And you'll get your negative version. Negative 7 pi over 6. So there you go. There's your positive and negative. A little bit quicker than converting, reconverting. All right, ready to go? Any questions here before we get to the last radian? All right, negative 7 pi over 3. Add the 360, 2 pi to it. All right, what's your common denominator now? 3. Keep the negative 7 pi. What should I multiply 2 pi by to get a common denominator of 3? 3, yeah. So that becomes 6 pi. Right? Yeah, I'm good. All right, guys, so you end up with negative pi over 3. And hey, that can count. That counts as your negative answer now. That counts as your negative answer. But I still need a positive one. Anybody got a suggestion how I can find the positive one? Keep adding 2 pi. So take that negative answer, negative pi over 3, and keep adding, yes, 2 pi to it. You already got a negative answer. Now I got to get a positive one. Hopefully this isn't too bad. You still got your 3 on the bottom. Now I have negative pi. What should I keep multiplying that 2 by?
3.
Yep. So plus 3 pi. So what's my positive version of a coterminal angle? 2 pi over 3. So again, instead of adding, subtracting 360, add and subtract 2 pi. And you guys can handle these fractions without a doubt. You guys can handle this. All right, take a breather. Any questions?
Wait, I'm confused.
Did I make a mistake?
I think so.
I think it didn't feel right for some reason.
You are supposed to make the 3 pi 6 pi over 3.
You're right. Sorry, one job. You got me, Ella. Didn't feel right. That should be a 6 pi. Thank you. 5 pi over 3. Thank you. Questions from you guys at home? All right, now to the new stuff. Now to this pre-calculus stuff I want to show you. You guys feel pretty comfortable graphing these angles and radians, right? But I'll tell you, like when we graphed 145 on number 1, I always say, okay, it's closer to 180, so make your arrow closer to 180. We got to get more detailed than that, get it closer to 180. So now what I'm going to show you guys is a different type of graph called a polar graph. Look at that thing, huh? This will be able to have our angles graphed more detail than just get it closer to 180. All right. So this is right on your screen right now and on your paper. This is called a polar graph. Hopefully you see your old school XY graph on there. Take a look in degrees now. Everyone see their old school XY is still on there. Right? This is still 90. That's still 180. That's still 270. And that's still 360 over there. But now we're going to get more detailed in between now. We're going to get more detailed. So what I need you guys to do first is, can you count up for me how many of these markings there are all the way around this polar graph? How many of these markings do I have total?
$24.
Do I have 24?
I think so.
Is it 24? Yeah.
No, probably.
He's right, 24. There's 24 of them. Why did I ask you to count? How many degrees did you just go all the way to count those?
360.
Okay, so you're telling me there's 360 degrees and 24 of those markings. 360 divided by 24? What's each marking represent? Yeah, go to your calc, yeah.
15 degrees.
15 degrees. Each one of those markings represents 15 degrees. So everyone ready with me? 15 degrees, 30. I just keep adding 15 degrees now. This is 45. This is, 60, 75, and look where we come to. There's good old 90. 105, 120, 135, 150, 165, and there's 180. Each marking represents 15 degrees on the polar grid. 195, 210, 245. Nope, that's not even close. How about 225? 240, 255. I don't know why I'm drawing a blank. There's 270. Here we go. 285, 300, 315, 330, and 345. And then we're back to 360. Okay. So that's how that is labeled in degrees. Now, I am not expecting you to do that ever again. Label all those out ever again. And you'll see why when we do an example to end class. All right, what's the radian version look like? We have degree version. What's the radian version look like? Well, what's 360 again in radians? 2 pi. And you guys said there's 24 of them, right? So if I divide by 24, what's 2 over 24 reduced down to? 2 over 24 reduces down to? Pi, yep, 1 over 12. So pi over 12. So let me get I want you guys to see, here you go. Here's your XY axes. Our old school XY axes that we used to graph on. So each marking is going to go by pi over 12. Pi over 12. Ready? Do it. Follow along with me. So the first marking, pi over 12. 15 degrees. Keep adding pi over 12s. Watch. This is 1 pi over 12. The next one, 2 pi over 12. If you want to reduce, you can. I'm not going to. 3 pi over 12. 4 pi over 12. 5 pi over 12. 6 pi over 12. And we can keep going on and on if you want. And keep counting all the way around. And you will end up at 23 pi over 12. Since there's 24 of these. All right? I'm not, just as long as you guys know they go by pi over 12s is what's important to me. You don't need to label the whole thing if you don't want to, go all the way around, but 7, 8, 9, 10. Okay? The polar grid goes by 15s in degrees, pi over 12 in radians. All right, you guys ready to use these at home? How we're going to use these? We're going to graph angles just like we did, but they're going to be a heck of a lot more detailed than what we used to have. All right, let's do this. Graph 105 degrees on this grid. 105. First thing, the one side of your angle is still going to be on the positive side of the x-axis. That's not going to change. It's still going to be right here at 0, positive side of the x-axis. The other side is, where the heck's 105? You go by 15s. Here's my advice to you guys. You know 90's right at top. Instead of in your head starting with 15 all the time, start pretty close to where you should be. So I'm going to start with 90 instead. All right, 90 plus 15. Oh, 105. There it is. And I'm going to continue the second part of that angle right up to it. That is a more detailed 105 degrees than if we just put it on the XY axis. Putting it on the polar grid makes it more exact. And yes, if you're wondering, I still need a rotation arrow. All right, guys, all good? All right, negative 300. If some of you guys are thinking, I got to go opposite direction, you're darn right I do. Same first side on the x-axis, positive side. Negative 300, so remember how it went. Let's see, negative 90 was down here. Negative 180 was directly across. Negative 270 is on top, so let's start from there. Negative 270. Keep adding 15, negative 285. Keep adding 15, negative 300. There it is. Hopefully I'm not going too quick through this, but I'm pretty sure you guys can pick this. You guys are picking this up. You go by 15s, find out where the end is. And rotation arrow, whoop, clockwise. Anybody struggling here? I need to go slower. All right, last one in degrees, 240. 240 degrees on the polar grid into 240. Let's put our first side on there. All right, 240, let's see. I know 180's right here, and I know 270's right here. So it's up to you. Do you start from 180 and keep adding 15? Do you want to start from 270 and subtract 15? All right, you guys can find where 240 is. There it is. However you want to do it. And don't forget your rotation arrow. All right, now let's graph in radians, but I don't want you to convert like we did earlier today. There's no reason to convert because you guys already know, again, they go by pi over 12s. All right, each marking is by pi over 12, so you just got to count to 10. That's it, you just count to 10, right? There's my one side here. Count to 10, 2, 3, 4, 5, 6, 7, 8, 9. Boom, there it is, 10 right there. Right, no need to change it into degrees. No need, no need. You already know it's out of pi over 12, so count to 10. Any questions from you guys? Well, what's the problem going to be sooner or later? What if it's not out of 12? right? Look at this next one. Negative 3 pi over 2. What if it's not out of 12? Make it out of 12. Sorry. Make it out of 12. If the denominator's not out of 12, we're going to make it out of 12. What am I multiplying 2 by to get 12? That's what I thought too. 6. Multiply top and bottom by 6. Done. Make it out of 12. So now this is really negative 18 pi over 12. So you got to figure out where negative 18 is on the curve or on the graph. So still same side, first side. Now remember, negative means I'm going clockwise. Negative means you're going clockwise on your grid. So where's 18? Negative 18. Or you can count backwards. Remember, this is 24, 23, 22, 21, 20, 19. There's 18 right on top there. Make it out of 12 if it's not. And as usual, this is negative, so I should be going clockwise with my arrow. Hopefully, you guys are doing some hardcore stuff here. This is some serious pre-calc here you're doing. Be proud of yourselves. And then the last one, 7 pi over 4. All right, it's not out of 12. How are you going to make it out of 12? Multiply top and bottom by 3. Make it out of 12. This is the same as 21 pi over 12. You can count 21 spaces around counterclockwise. But remember, too, the end here is 24 pi, right, out of 12. There's 24 markings, so if you want to work backwards, you can, too. 24, 23, 22, there it is. And then where are we going? Counterclockwise, right? Because it's positive. Yep. There it is. All right. So welcome to we're going to be doing all our graphs on this type of grid. We're going to graph points. We're going to graph actual graphs that look like different objects. All right. All right, guys. So on Monday, you're going to do the day 2 assignment, which is exactly like our notes. You can't go wrong. And submit them in the classroom. All right, I'll see some of you guys on Monday in class. If not, I'll see you at home. Nothing stronger than ginger ale this weekend. Behave. See you guys.
I'll be Monday.
What's that?
I'll be there Monday.
You in person?
Yeah.
Let's go, Caroline. Let's go. Maybe I'll be absent. Can't wait.
Bye.
Bye.